Hello and welcome to this quick tutorial on Asm4GCN. So first off, you probably want to download it. So you can download it by going to Google and type GCN Assembler. And you're looking for this link right here, GCN Assembler for AMD GPUs on Code Project. These are all great assemblers, by the way, so there's several of them, and they're mostly all on this page right here. But I'm going to click this one. This is the article for the project. You can see if you look at the contents, you can read about it. But here is the download link. So if you just want to use the download link, this is what I'll be using in this tutorial. You can use this one here. You could download a more stable sort. If you want to download the source code, you could download it here. And if you want the latest source code, maybe not always the most stable, you can download it here at GitHub. So what I'll be doing is I'll be going through this article off to the side here and showing you a little bit about this. This here is the, let me open up the program folder. So when you launch this Asm4GCN GUI, it launches this here. So there's several files that's part of this project. At the lowest level is this one here. This is the assembler itself. It's a command line based thing, so you can use it for the command line. You put an input file, and you can use this test input one as an example, and then you can output to the other file. If we open up the command prompt, let's show that. You can get the input and output. So we will do Asm4GCN, and we will do, I think it's called test input.txt. Test input.txt. Oh, we need output. Output.bin. It looks like this ref command that's from an earlier version. I no longer use that, so I should go in here and take that out. So the version you download will have that, but you can delete it. So let's try that again real quick. So there it is. So compiled, and if we do a dir, we can see the file is now there, output bin. So, and there's that output.bin file. So you can use that in other projects. I won't go too deep into that right now. So this is the main assembler. This here is a layer that runs on top of it. This allows you to use, assembly kernels with OpenCL kernels. The main function of this DLL is it creates a OpenCL generic kernel binary, and then it replaces the contents of that kernel with the one that is created by this one here, the binary, the one that we just deleted. It puts that bin right inside there, and then it runs it. So that's what this does. So it's kind of like layers. So this is the center layer, this is the next layer, and then all the way at the very top of that is this one here. Is this the GUI, like if you want to use the GUI. And the GUI needs a couple files to work. It uses this OpenCL, which is a great library I found, a OpenCL to C# wrapper. It's written very nicely, by the way, so I like that one. This is a fast colored text box. It's in my article, and this is the autocomplete menu in my article also. A lot of the cool stuff in this thing is directly from this project, but just search online for fast colored text box and autocomplete menu. So let's launch this, and in here, this is the Gui window. So we have two parts here. So we have the C# code right here, and this is a nice example here, by the way, that I got from Derek. There's a reference on my code project page. But anyway, I used his example here. It's laid out really nicely and clean. And also the OpenCL, the wrappers for OpenCL, that's where this also takes place too. And what I like about OpenCL is it stays really close to OpenCL. You're not using, someone's interpretation of OpenCL. You're kind of using, real close to real OpenCL. So if you ever switch libraries, it wouldn't be, the end of the world. So yeah, it launches. We have two windows here. We have the C# window, and then we have the GNC, or I always do that, GCN code. So this is the assembly language, and see, this is the kernel. You can actually have multiple kernels in one program. This is a kernel down here, but you can't call assembly kernel from an OpenCL kernel. So if you're wondering if you can do that, you can't. But you can't have them in the same program though. So you can call this kernel and then almost immediately queue this kernel right after it. So this kernel up here was really almost 99% generated just from this. So I ran this through one of AMD's products. I can't remember the name, and it generated this up here. So I kind of also use that as a test, because if it can do that and this works, then that's great. So this is the C# window. This is the assembly window. Everything up here should look pretty normal. New, open, save. I won't go through these. Print, cut, copy, paste. Used to run it. So let's run this project. And yay, it computed all the correct values. So exciting. There's no real debugging on this. One cool note is when you do run the save, and if I open up that temp file and look in it, there's the whole program. And what's neat about this, how it saves, is it wraps it in a namespace and then wraps it in a string. So really, if you save it, directly in here, you could pull it up pretty much in Visual Studio and just add a reference to the needed DLL files, and you're on your way. So you don't need to do a lot of converting, because I know you probably don't want to work in this IDE as little as possible. So yeah, so this app has some little features, color highlighting over here too. It has a little bit of code completion, which is again from the autocomplete menu item. Just Google that and you'll find a code project site for that. But yeah, if you just do *_ there, you can go through here and find what you need. There's a little bit of help in there, what the instructions do. DS is a data set instruction, S is a scalar, and V is a vector. So you can add those. But that's about the end of the help. The rest you just gotta to know. Okay, so let me show you the kind of this language. So there is assembly, and then I added some little flavors to it that I thought would, help me. And they're actually demonstrated here. So one is define. So this is much like the C++ or C define that you know of. You could do define, what you want, and then it replaces that. So if you find that down here, this right here is really just going to get all of this stuff. It also supports parameters. So if you did like n or something, I can't remember offhand, but it would, do that also. Variables. Working with register numbers is a pain, and variables really help. So I kind of came up with my own little system of numbers, of types. So the first letter is the type. It's either S or V, because you either have scalar or vector variable types. This is the size in bytes. So you have typically 4 or 8, but you might have 16 too, like for these right here. And then the last one is the type. So it'd be unsigned, unsigned. B could be bool or bit. There's no real difference, but you also have F for float. Now this last one really isn't used yet, but I want to have a little type checking in the future, but it's just there now already, but the actual type checking is not there yet. So if we look in here, we can see the type, and then the variable name, and then this part is optional. So you can specify the type, give it a variable name, and say I want to give it registers 2 and 3. Assign it to here. So this would be a 64-bit value. And always at the beginning of a function, you're going to need these, because when the kernel starts, certain registers have certain values pre-populated, and these you just kind of going to have to look up to know or find some example kernels. But these are pre-populated, and same with V0. This is also pre-populated. So the lane ID 0 through 64 is saved in V0. So that's why those are specified, but you don't have to. See, if you look down here, these are just being created, and the way it works, this register system, is whenever it hits a variable, it selects the very first available register. So in this case right here, I'm kind of looking at this, S4U is probably going to use S0 because it hasn't been used. This one's probably going to use S1 because I do not see it already used. If we declare the next one, another one, if 2 and 3 are used, 4 through 7, 8 through 11, 12 through 15. So this, if we did, an my address 3, it would be probably S16. So that's kind of how that works. And then it reserves that register and it holds on to it. So this will be S0 constantly or continuously until you get to a free command, and returns that register back to the register pool. So the next time you use a variable again, it's free to grab from that pool. So it's kind of important to free them as you create them. And again, you could just use V0 if you wanted to use vector 0 there. So there's a vector, like here's a vector, so you can use V2 there. I'm sorry, actually this would be S2 or something for scalar. Yeah. There's a third command here. So there's free, there's the declaration, there's the free command, and there's also a rename. The rename, which I'm going to probably change in the upcoming version, is often when you're writing assembly, you declare a variable, that's a register, but the meaning of that register could change in an instruction. So example, lane ID, lane ID. So here, this lane ID, I'm not sure don't remember, but we're doing an operation and we're saving it back to lane ID. So maybe this was lane ID, but I can tell you this is probably not quite lane ID anymore. So you would need to use a rename there. So actually I'm not going to use that, but if we do rename lane ID to new name, we can do that. So this actually kind of shows the problem with rename. Rename is a statement, so you can't use it in an assembly statement. So if you do put this here, if you did the rename here, this might be new name and this might be lane ID. That makes sense, but because it's its own statement, it has to be that right there. So you kind of have to do it early. So anyway, so that's probably going to be changing in the next version. I might do something like new var, it might be kind of like that or something. So those are the variables. Next are labels. Labels are pretty cool. So with a label, you can get yourself into a lot of trouble, because if you do an infinite loop, it gets stuck you basically have to reboot your machine to get it back, at least my machine. So, okay. So labels are pretty cool in that you can go my label and you can branch to my label, and always the labels have to start with an @ sign. So if you run this, it's just going to jump to here. Yep, cool. If you change the order of these, it would lock up the video card, their GPU, I mean. All right, so those are labels. Labels are kind of cool in that when you use a label, it's really just turns it into a value. So when it goes to compile it, it turns this into a value. So this is always the distance from the label. So this, I could tell you, would be actually 0 because it's the distance from the next. So this would just translate to 0. But if you had my label down here, this would be 1, 2, 3, 4, 5. So that would be 5 words away. So really this would turn into a 5. Actually, we could probably even run that. Oh wow, it even came back with some right values. I didn't expect that. So really, actually if we run this, I think we'll also get a 5. We didn't get 5. I wonder why. I think 5 might be here then. Yes, so that would be 5 actually. So this is just a distance. So you can use a label anywhere. It doesn't necessarily have to be on a jump instruction. So say for some reason right here you wanted to do a v, move b32 to vector 1, and you wanted to move that. So that would basically move the distance from here to there into there. So this always gets resolved with the distance to that label. 1, 2, 3, 4, 5. So that would turn into a 5 there. I also chose to reuse labels. So sometimes when you're writing code, you like to use your favorite labels, like try again, for example. And what this will do is if you use labels over and over again, so you use these here and use these here, right? Good. Why is it coming up with an error? Anyway, I'm not going to debug it right now, but you should be able to use labels over and over again. So whenever a label is used, it finds the nearest match. So here it would be this one. This one would be this one. I'm sorry. The use would go to the nearest label. So this one will go, where's the nearest one? It's right here. Now that could be dangerous. It does throw a compiler warning. So you will see it already exists. References will use the nearest label. So you can use them, but it's going to throw a warning. So something about labels. Oh, you know what? Going back, I just remembered there's indexing on variables. Let me fix some of this up so we're back working again. I think that should work. Great. I busted. I'm just going to hold down Control Z. Put everything back. There we go. Now we should run. Wonderful. All right. So you can use indexing basically if you have a multi-address register. So say like address 0 here, you can access the second register. By default, this would be S2, right? So this really just gets translated to S2 here. It points to S2, but this instruction knows to use S2 and S3, so it does use both. But sometimes you might want to just use S3, but if you use the register, there's no real way just to access the second one. So you can use this, but this one makes sense here because this would using S3, and since this is turning into a 64-bit, this would not work that well. But you can use it where the register is expecting a 32-bit. Basically, all it does is if you see S2, converts that to an S2. But if you have an index of whatever, an index of 3 here, which that would be a very big variable, then it really would just take that S2 and really add 3 to it to make it S5. In this case, this instruction, if you did that, it would use S5 and F6. Actually, it wouldn't, because that'd be a failure. But I won't get into that part, because you can't start a register on a multi-register in an odd number. But, all right, let's back out of here. Okay, so one cool thing is, let me bring this window down over here so you can see it, is the constants are very flexible. This thing will take almost any kind of constant you could throw at it. So you can use just normal indexing registers, you can use hex, you can use exponents, negative exponents, float. So if you put a decimal point in there, it's automatically going to turn that into a float constant. So anything with a period, note that it's always a float. You can use octa, you start with 0O instead of 0x like hex, and you can use binary 0B. So it's very flexible numbers. So here, if you wanted to, you can do B. And I was thinking it needs to be 32 here, but it doesn't. Okay, this project has a pretty cool text template engine that we can use here. Basically, it's kind of like a component that right when it compiles, it expands certain parts of code. I guess maybe I'll show you. And this is really useful for assembly, because sometimes there's no like unroll command, which is sometimes when you're programming at that level, you want to unroll things. But this is kind of a substitute. So I just copied and pasted this from my project. So if you look here, and by the way, this didn't format right. So it's not supposed to look like that. It's not supposed to have this stuff here. It's just supposed to have that. But anyway, so if we look over here, anything in these brackets, it's going to treat like code. So if we look at this here, it's going to expand this to, it's going to go from 3 to 7. So it's basically going to print this move 8 to 4 and then 9 to 5. So if we run this, I wish that we can see the expanded code. But anyway, so if you look at this, this would basically turn into move B32 V4 comma V8 V. I'm just going to copy that. So you see that, so that's that V. Whenever you have this command, and I made an article on this on Code Project that goes really in depth on this. You can use it for other projects too. It's kind of like a universal thing. It's called Text Template Engine. So this here is would get expanded. So you get that. The V, you get the V, but then you have these weird brackets. You have double brackets here and double brackets there. So the double brackets indicate code. Equals I is going to just bring back whatever I is. This is the code for up here. This code is going to be, 3 and 7, 4 and 8. Okay, and then that's the end bracket, and it's going to do it again. But I is going to be 4, and then I is going to be 5. So basically behind the scenes, this right here is expanding right into that. And you could pretty much do anything you want here. This is C# code. So whatever you pack in there, you can do whatever you want. One nice thing might be like you could do, here's my other example on the Code Project site, but if you had that, for example, that would really translate into that. So basically it's just going to take the date time now and stuff it right there, and that's what we get. So that's text templating. It's basically code that generates code. Microsoft has one for their Visual Studios called T4. I made my own version called, I don't really give it a name, but I use this kind of terminology, in the double brackets, because I think it looks a little cleaner. But yeah. All right, well, that pretty much sums up the Asm4GCN.